Video lesson 14.6, the equation of a tangent line. So we're just going to take the information that we've kind of learned so far in this unit and apply it kind of together. So we're going to come up with the equation of a specific line that's tangent to a circle. So we know what a tangent line is. We know that it intersects the edge of a circle or a curve at exactly one spot. And we know, if you remember back, the property that says that if we have a radius or a diameter that intersects that tangent line on the edge of the circle, then it will be 90 degrees at that point. So we're going to utilize that from there. So let's look at the first example and check this out, and then we'll kind of work backwards, kind of working from here. So if we look at this first, right, we've got a circle here with circle O. So A to B would be the diameter, right? So that means OA and OB are both radii. So we could come up with an equation of a line that intersects both A and B, and that would be tangent to this. So you're going to have two that are going to be two tangent lines with any radius or diameter, and we're going to be able to kind of utilize that from here. So if we think about what the slope of this would be, let's see here. So the slope of, again, either OA or OB, it would be the same thing, right? What is that? That's down 1, right 2, right? So that's going to be a slope of -1/2. Now, what would its tangent line's slope be? Well, if I have a line here, right, something like this, that's going to be tangent at O or at B, the slope must be perpendicular, right, to that. So the tangent, I'm going to just say tangent slope, right, would equal perpendicular slope to what's here. So that's going to be, in this case, opposite reciprocal. So flip it and negate it, so you get a slope of 2. So this is the slope of the tangent line. All right, so now I know that my m for this equation is going to be 2. And if we think back again, whatever version you like, I like to use point slope form. So that's going to look like this, right? I think this is going to be much easier because I first found the slope. As long as I can come up with a point for x1 and x2, I now have the equation. So we know what point A is here, right? At this one here, it's -1, 1, 2, 3. So this is -1, 3. So now I've got A at -1, 3. And I've got B at, what is this, 3, 1. So if I wanted to create the equation of a tangent line, right, I can now say that y minus 3 is equal to 2, because m is my 2, times x minus -1, which is going to be +1. So that's the equation of the line at 1. I'm sorry, at A. That's tangent to the circle. And if I use B instead, that would be y minus 1 is equal to 2 times x minus 3. This would be the equation of the line at B. So we just found, right, this line and this line, right? And they're parallel to each other. And that makes sense, right? Because they're 90 degrees on both spots. So they would have to be parallel. So that's the idea. Now, reality is most of the time you're not given the information in a graph, or you may not be given the information directly with some of this. So we have to kind of sometimes manipulate the information. So if we are given in a graph, like example 2, much easier in the grand scheme of it, right? So let's look at number 2 here for a second. So we've got what do we got? They're telling us here that find the equation of the tangent line to circle with slopes of 1/2. So they're telling me the slope of the tangent line. So they're telling me that, and I'm just going to abbreviate that as t with a little m, right? Oh, sorry. I meant m with a little t, slope of the tangent, right? They want that to be -1/2. So that would be my m in my equation of y minus y1, m times x minus x1. That's my m, negative 1/2. But we don't know the points. We don't know what the points are on this graph, so we got to work backwards. So that means, in this case, if the slope of the tangent line is 1/2, its perpendicular slope would be 2, right? So I'm going to have a slope that is that's perpendicular to that, aka the radius has a slope of 2. So if I go to the center point and I go up to right 1, that gives me that point, right? If I go down to left 1, that would give me a point there. So these would be now my 2 points that this tangent line would have a slope of 1/2, and that would be this way and this way. All right. From here. So let's label this. I'm gonna, since this is called circle A, let's label this. We'll call this B, and we'll call this C. So now I've got point B. So B is, what is that? -2, comma 1, 2, 3, 4, 5. And C is -4, comma 1. So we've got our points, we have our slope, right, of the tangent line, and now I can just write it into this form here. So that's going to be y minus 5 is equal to -1/2 times x. Again, minus a -2 is +2. There's the first line. And the second one, y minus 1 is equal to, again, -1/2 times x minus a -4 is +4. And there's the equation for the second one. And again, you can check that, right? If I plug that in, right? If I look at this here, right, this should be something like oops. There we go. Something like that. And that would be the same kind of a deal here. Something like that for that one. All right. So, actually that's off a little bit myself. That's better. All right. It should look something like that. All right. And again, with the graph, it's definitely not terrible. The tricky part is making sure you're careful here in the context and what they give you, right? They gave me the slope of the tangent line. They might give me the slope of the radius, right? So you just got to be careful as to which one they're giving you. All right, last one, and then we'll let you guys practice some of these. And that is, what if they don't give it to you in a graph, right? So the best thing to do here is sketch, right? To sketch your work. So real quick, let's just give a quick little sketch here. They're telling me the equation. So out of this equation, I can get the center, which is 2, 0, and the radius, which is rad 10, right? So that's all the information I get out of there. So at 2, 0, so 1, 2, here's my center, right, of the circle, right? And they're saying here, there are 2 lines tangent to the circle having a slope of 1/2. So the slope of the tangent line is going to equal -1/3. And I'm abbreviating slope with little t for the tangent line, right? So that means the perpendicular slope is going to equal 3, aka slope of the radius. So from here, right, I want to go up 3 over 1. So I want to go up 3 over 1, right? So 1, 2, 3. Make a couple marks here, make it easier to count. All right, so that would be here. So that's going to be, we'll call this point A. And if I went the opposite, I'd go down 3, left 1. We'll call that B. All right, so what are those 2 points? So A is going to be, what is this, 3, 3. And B is going to be 2, -1. I'm sorry, 1, -3. Okay, So again, that's the tricky part here, is being able to figure out what those points are, and you don't have a graph. So again, just to make your lives as easy as possible, sketching it out is fine. Now, how do I know that it's definitely these? It couldn't I have gone up 6, right 2? Right? Wouldn't that have also given me a slope of 3? Or down 6, left 2? Right? So there are possibly other points, right, out here that it could have been, right? Because this could be the simplified version. So I got to check those. I got to make sure that those are correct. So there's a little added step. So I got to do a little quick check, right, that these points work. All right, so all we need to know is that the points have to be on the edge of the circle, right? So if I was doing this, right, this would have to look something like this, right? Just real quick. So if that's the case, the tangent lines have to be on the edge of the circle, if that is in fact the circle. These points are on the circle, so, and tangent to them. So I'm going to plug these back into the original equation. So I'm going to say here, x minus 2 squared plus y squared equals 10. I'm going to plug these numbers in. So I'm going to say 3 minus 2, this was all squared, right? Squared plus 3 squared. Does that in fact equal 10? Well, that's 1 squared is 1, 3 squared is 9, so 10 does equal 10. So that means point A is in fact on the edge of the circle. That's good. So that means B should be as well, but let's just double check, right? So this was A. For B, right, we're going to check that one also. So that was 1, negative 3. So we're going to say 1 minus 2 squared plus negative 3 squared. Does that equal 10? That's negative 1 squared is 1. Negative 3 squared is 9. So 10 does equal 10. So that one worked as well. So now I know that both of these are good. They both work. So now I can go right back into just writing the equation of my line. So y minus 3 is equal to, slope of the tangent line is here. This is our slope of our tangent line. Negative 1/3 x minus 3. There's your first equation. Second one, y minus negative 3, so that's plus 3. Again, slope of the tangent line is negative 1/3 x minus 1. And then we have that final piece. So again, these are definitely tricky, to work with, but it's a good thing to practice and try and do your best with. Again, especially when you don't have the graph, I recommend at least sketching it just to come up with what those points are. And again, be very, very careful and being of what they tell you, what slope that you're given, or whether you're given the slope of the tangent line or slope of the radius or whatever the case might be. Just label it and mark it so that you know everything's correct. Okay. With those. All right. So anything you're not sure of, make sure you go back over the video make sure you get some good notes, and then utilize the practice problems for better understanding.